Welcome to this lesson on the Pythagorean identities. Now, having looked at sine, cosine, and the other trig ratios, we're now turning toward what are called identities. Now, identities are different from equations. Equations are only true depending on what you plug in for x or y or some other variable. But identities are always true, regardless of whatever you plug in. So what we're going to be looking at is what's called the Pythagorean identity. And what we're going to do is we're then going to show why it's true, and then we're going to use it to find other unknown trig ratios. So when you read Pythagorean identity, you think Pythagorean theorem. And you should, because it comes to us from the unit circle. With the unit circle, the hypotenuse has a length of 1, and the vertical leg has the sine of whatever that angle is, and the horizontal leg has a value of cosine. Well, the Pythagorean theorem still applies to this. So if we take this squared plus that squared, it should equal 1 squared. And that is what the Pythagorean identity says it is. So sine squared plus cosine squared is always going to equal 1, which makes sense. No matter what point you pick on the unit circle, if you take sine and squared and cosine and squared, you will get 1, because the hypotenuse will always equal 1. Now, underneath this is also two other identities, but they're still grouped under what's called the Pythagorean identity. And so the first one is sine squared plus cosine squared equals 1. The second one, tangent squared plus 1 equals secant squared. And 1 plus cotangent squared equals cosecant. Now, these are harder to visualize as a right triangle, but the important thing is that both of these come from this first one. And the first thing I want to do is I want to demonstrate why this one, how it comes from the original sine squared plus cosine squared equals 1 identity. We've already established that as being true. So I'm going to write sine squared plus, always make sure you write the angle, sine squared theta plus cosine squared theta, theta equals 1. Now if we look at this, sine squared has to become tangent squared, cosine squared has to become 1, and 1 has to become secant squared. Well, since it's true, this equation, we can only do the same thing to everything. Now the key is that, wait a minute, cosine has to become 1, and all we're allowed to do is multiply or divide. So what I'm going to do is, in order for cosine squared to become 1, I'm going to divide by cosine squared. Well, if that's true, how does 1 become secant? Well, that's going to be because we're dividing by cosine squared. And if we're doing that here and here, we're also doing that here. So we're going to divide the entire Pythagorean identity by cosine squared. Now, sine squared divided by cosine squared. Well, we know that sine over cosine is tangent. So sine squared over cosine squared should be tangent squared. Now, cosine squared over cosine squared, that equals 1. And 1 over cosine squared is secant squared of theta. So, starting from what we know was true, that sine squared plus cosine squared equals 1, we then divided everything by cosine squared, and that gives us this one. So now we know that this one is true. Now part of your worksheet will be to prove that the other one is also true. And it's done in almost the exact same way. Now what we want here is we want to use the identities to find sine of x and tangent of x if cosine of x equals 0.8 and tangent of x is less than 0. Okay, well, we know that sine squared x plus cosine squared x equals 1. Now again, the fact that we're using a different letter, as we're using x instead of theta, that has no effect on this. This identity is still true. Now in place of cosine, I'm going to put 0.8. Now the reason that we put a squared here is to tell us that we're squaring the entire quantity. If we put a squared after the x, you would think that it's only the x that's being squared. By moving the squared up here, it's telling us that the entire cosine is squared. All right, so sine squared x plus 0.8 squared is 0.64 equals 1. And if we subtract 0.64 to the other side, we get 0.36. Now we have to find sine. Currently we have sine squared. So that means we have to take the square root of both sides. So sine of x equals, now if you just forget the decimal is there, square root of 36 is 6. So the square root of 0.36 is 0.6. Now the thing to be aware of is that at this point it could be positive or it could be negative. And this is important because we don't know where this angle is. We know cosine is positive, but all that means is that the angle is either in the first or the fourth quadrant. So sine could be positive or sine could be negative. We don't know. But what we do know is that tangent is less than 0. So tangent has to be negative. Now tangent is sine over cosine. So one of those two has to be negative. And since we already know that cosine is positive, that means sine has to be negative. So sine equals negative 0.6 because tangent needs one of those two to be positive, one of those two to be negative. So to find tangent of x, well, we know that that is equal to sine of x over cosine of x. And we already said that sine of x is negative 0.6 and cosine is 0.8. Now, since we have the same decimal within the fraction, we can just drop that and say negative 6 over 8, and we reduce that to 3/4. Let's do another one like this. We want to find secant and cosecant if tangent is equal to 3 and cosine of x is greater than 0. So right now we have that tangent is 3. Okay. So since we know this, we have to use the identity that uses that. So tangent squared of x plus 1 equals secant squared x. So now we'll substitute 3 in for tangent. But again, tangent is being squared. So it's 3 squared plus 1 equals secant squared x. 3 squared is 9. That's equal to secant squared of x. And so 10 is equal to secant squared. So to get rid of the square, we take the square root. And that means that secant is equal to, secant of x, excuse me, is equal to plus or minus square root of 10. Now we know that cosine is greater than 0. Well, if we think about it, we know what secant is. Since we know what secant is, cosine we also know. That's 1 over plus or minus square root of 10. Now, we don't like radicals in the denominator, but that's not the point. I'm going to leave it there because we know that cosine has to be positive. And so in order for this to be positive, we should have 1 over a positive number. And so that means this has to be a positive, which means so does this. So secant of x has to be positive square root of 10. And not negative. So this must be positive. Now, we also need cosecant. Now, how do we figure out cosecant? Well, we can use the other identity, 1 plus cotangent squared x equals cosecant squared x. Now you're saying, well, wait a minute, we need to know cosecant, but we don't know cotangent. We need to know that, and we do. However, keep in mind, we know tangent, and tangent and cotangent are reciprocals of each other. So since we know that tangent equals 3, cotangent has to be its reciprocal, 1/3. So when we square 1/3, we get 1 plus 1/9 equals cosecant squared. When we add these, we get 10 over 9 equals cosecant squared x. How did we get that? 1 we just rewrite as 9 over 9, and then we add 1/9 to it. So to get cosecant, we take the square root. Now, the top is just going to be square root of 10. The bottom we can take the square root of. That will be 3. Whoops, there should not be a squared there. That should just be cosecant of x. We've taken the square root, so now it just reads as cosecant. Now the last thing to figure out is, well, is it positive square root of 10 over 3 or negative square root of 10 over 3? Well, let's see what we have been given. We know that tangent of x is 3, and we know that cosine of x is greater than 0. Now, tangent, that's sine over cosine. And if we're taking sine over cosine and getting a positive answer, that means both of them are either positive or both of them are negative. But we already know that cosine is positive. So that means sine has to be positive. And if sine has to be positive, then its reciprocal, cosecant, has to be positive as well. So it's not negative radical 10 over 3, it's positive radical 10 over 3. All right, take some time, refer back to the identities, come back after you worked on the worksheet, and we will see how you did.